about light entering the block, and quite a few little questions related to this. If my voice sounds a bit funny, it's because I'm running a little bit of a cold at the moment, so you'll have to excuse me if my voice starts to squeak a bit. So the angle of incidence in figure 1 is shown as labelled I. In figure 2, use letter R to label the angle of refraction. Okay, so here's our angle of incidence. So this is our angle of refraction. And if you forget to put an R in it, there is no reason why the examiner needs to give you a mark for it, because it does say put the letter R on there to label it. Okay, we've got a protractor that's used to measure this. What's the resolution of the protractor? So what's the smallest division on our protractor? We look at one of these tiny little divisions. What does one of those represent? And one of those represents 1 degree. So the diagram below shows a ray of light moving through glass. Which diagram correctly shows what happens when the ray of light strikes the surface of the glass at the critical angle? Okay, well here the light's not at the critical angle, it's coming out of the glass. Here we've gone past the critical angle because the light's being reflected back into the glass, total internal reflection. Here we're at the critical angle because we've just got to the point where refraction is sending the light down the surface of the glass. So that's our critical angle there. So we've got a concave diverging lens. Diverging lens, so we're talking about one that's shaped like that. When the light's going to come in and the light's going to diverge, it's going to spread out. Okay, and we can see that we've got a beam of light coming in here and heading off that way, and from the same way there, it's sort of heading off in that direction as well. And this is where our image has been formed. Okay, so we need one word that describes the nature of the image, and we've got a choice of 3. We can say that actually the image here is smaller than our original object. So we can say it is diminished. We can say that also it's on the same side. Here and here, these are on the same side of the lens, and that means that our image is virtual. And if we look at this, our image is pointing in that direction, and sorry, our object and our image is also pointing upwards. So they're both pointing the same way. So it is also upright. So we can choose any one of those. Diminished means it's smaller. Virtual because it's on the same side as the lens as the object, and upright because it's not being turned upside down. Okay, so looking at this, can we calculate the magnification? How many times bigger is the image? Well, if we look, it's not bigger. If this was bigger, we would say, okay, what is this size divided by this size? But actually, it's smaller. We can do it the same way. We can say our image is 1 centimeter, and we divide it by the original size, so it's a quarter. It's 0.25. The magnification is 0.25. 1 divided by 4, 0.25. The image is a quarter of the size of the object. It will look smaller than it actually is, which, if you notice, they talk about this being in a security spy hole. So it's one of those peepholes in a door where you look through the door and you get a very wide angle of view, but everything looks smaller. They sometimes call it a fisheye lens. Okay. So what's another use for concave lens? Another use, well, magnifying glass. No, if you look at a magnifying glass, the lenses look like that. And if you look at a camera, the lenses look like that. So our only one we've got is for correcting short sight. If you've got short sight here, then the light coming in is getting focused too soon, too early. So if you put a diverging lens in there, then the light coming in will get spread out slightly so that it is getting focused to the back of the eye. So it is correcting short sight.